Hi everybody, we're going to start our very first chapter of video lecture. This will be a whole series of small videos put together to cover the key points in the chapter that you really need to understand. So we'll see how many videos it takes to get through chapter 1, but it will certainly take several. We're going to start with defining the word statistics. It is the core of the course. It is the central heart of it, right? It's on the name of the class, it's on the name of the book. It's what we're here to learn. We're going to find that there are several uses or a handful of different uses or ways of using this word, defining this word. But when we were referring to the science of statistics, we're referring to a set of mathematical procedures for organizing, summarizing, interpreting, and communicating information. Organizing, summarizing, interpreting, and communicating. That's almost identical to what the book says. I added a term there I'll point to in just a moment. So organizing, research usually revolves around hundreds of measurements, and we need some tool, statistical tools of work, to help us keep all that information organized. It keeps us from making mistakes. To summarize, to get the gist of the information. If my boss asked me, Paul, how old are your statistics students? Well, I could send out a survey to all of you and ask you how old you are. So you all, how old are you? And you all tell me how old you are, and you send me back the responses. And my boss said, hey, did you ever find out how old your stat students are? And I said, sure. There's one who's 18, there was one that's 19, there was one that was 26, there was another 18-year-old, there was one that was 27, there was one that was 16, there was one that was 37. I would expect him to slap me by now, right? That's not what he wanted to hear. He didn't want me to give him a list of everybody's ages in random order. What do you suppose he probably wanted? An average, right? He wanted me to summarize that information. On average, how old are my stat students? So that's our summarizing. Interpreting, what we'll be focusing on quite a bit in this course, is what the numbers are trying to tell us. One of the things students don't quite understand about research in the beginning is that they think the conclusions are obvious, and they're never quite obvious, but that we're going to use these mathematical tools to help us sort of objectively draw some conclusions. So we've got to interpret our data. It's up to the human to figure out what the results mean. And then lastly, the word I added to the definition from the book is communicating. Statistics is a language, and it doesn't matter if you are in the science of biology, or astronomy, or psychology. We use slightly different tools inside of statistics, but it's all the same language. If you can speak statistics, then you can speak to scientists. You can clearly share your ideas with them, and you can more clearly understand what they're trying to tell you. So it is a communication tool. It's sort of a standard science language. So that's our sort of general definition of the word statistics. We're going to see here in just a few minutes some other ways of thinking about that term, but that gets us the gist of it. Now, if we're going to do research, what we're trying to do is answer some question. We're trying to figure out, does this treatment work, or does this cause that to change, or is this the result of your upbringing, or there's some question we're trying to get an answer to here. And what has to be specified in that question is your research population. We all know the word population from just general English usage, but in research, sometimes we mean something a bit different by it. So sometimes you'll hear researchers call it a target population. Sometimes they'll call it a universe or just a research population, but we usually just say population. When we are in research talking about our population, we're talking about the collection of all the people we're interested in answering that question about. All the people we are interested in learning something new about. So if I want to know what the favorite flavor of ice cream is for college freshmen, for some weird reason, then my research population is college freshmen. Which college freshmen? Well, in this case, all of them. If you go to any college or university anywhere and you're a freshman, you were in my question. But I could narrow that down. I could say I want to know what the preferred flavor of ice cream is for college students in the United States. Now I've just redefined that population to a slightly smaller group. Or just, I want to know what the favorite flavor of ice cream is for college students in the state of Nevada, or college students at CSN. So the researcher can specify, who really am I trying to answer this question about? Sometimes it's anybody and everybody, it's all of humanity. And sometimes it's a very, very specific group. But that becomes part of writing our question, is being clear about who are we asking about here. Now, if we go to our population, so let's go with the small one. I want to know what the favorite flavor of ice cream is for freshmen attending CSM. So that means, well, right now we're all pretty much remote, right? But if we were at the North Las Vegas or West Charleston or Henderson campuses, any of our remote extension campuses throughout the county, prison schools, remote schools out in Air Force bases or out in Sandy Valley, all of those. If you're a CSN student, you count. And so I figure out that what the preferred flavors are, write up a whatever survey question, I get those results. The results I'm going to get back would be called a parameter. So a parameter is a value, usually numerical, that describes an entire population. So again, a parameter is a value, usually numerical, that describes the entire population. So I get every freshman at CSN to tell me their favorite flavor of ice cream, and let's say, just for the sake of a simple example, 50% say chocolate is my favorite flavor. Well, 50% saying chocolate, that value is a parameter. It describes the entire population at once. The problem is, in the real world, we almost never get to do that. We've got thousands of freshmen. Our school on the whole is usually is around 30,000 students. We're one of the larger schools in the country. We're certainly the biggest in the state. And so sometimes we're a little lower than that, sometimes we're a bit higher than that, but we tend to, over time, balance out around 30,000. And since we're a two-year school, a bunch of those are freshmen. So let's just say it's half of them. Again, easy math. 15,000 CSN freshmen. Well, the question is, what's the favorite flavor of ice cream for these 15,000 CSN freshmen? Well, if we stop to think about it, realistically, what are the odds that I'm going to get every one of those freshmen to tell me? First problem we're going to have is, how do I even know who these people are? I legally can't go into the school's database and get without reason to get a list of all the freshmen. That's a violation of privacy. So how am I even going to figure out who these people are to ask them? Do I have correct phone numbers and addresses? For a lot of you, your information in the system is not correct. It changes faster than we can keep up for some of you. So who are you? And do I even have the information to contact you? That already is going to make it impossible to get all 15,000 folks. But now let's say I call you and I say, hello, my name is Professor Billings. I'm doing a brief survey. Click, you're going to hang up about that fast if you even answered in the first place. You don't have to participate. Even once I get a hold of you, you can say none of your business and hang up on me, right? So in reality, we're almost never going to get to work with the entire population. It just isn't possible in most cases. You might in some cases have a very small population where you can get everybody, but in almost every real world situation, it's simply impossible. So instead, what we work with is a sample. The sample is the group of people taken from the population who do participate in the research. So if I managed to track you down and I asked you, would you complete the survey, and you said yes and do, then you are in my sample. So again, the sample is the group of people taken from the population that do participate in the research. So my sample should still be CSN freshmen. It just won't be all of them, it'll be some of them. Now, when they return their information and I find out that, we'll say the same number, 50% prefer chocolate, I don't have a parameter because I didn't measure everyone in the population. What I have is a statistic. So here's another use for it. We talked about it at the very top, defining it as the science of statistics. This usage is defined as, here, a statistic is a value, usually numerical, that describes a sample. So we said a parameter was a value, usually numerical, that described a population. A statistic is a value, usually numerical, that describes the sample. Notice that how much more common that would be. We don't have the word parameter on the book. We don't have the word parameter in the course. We very rarely use the word because we very rarely work with everybody. We usually just work with some of them. And so that value that describes them to say, oh, 50% of the sample likes chocolate, prefers chocolate, that is a statistic, something that describes the sample. So one of the things we have to be concerned about in research is called sampling error. No sample is going to be perfect. This group of CSN college freshmen isn't going to be perfect. I might not represent all the different ethnic groups exactly proportionate to the population, or gender groups, or age groups, or majors. I might accidentally have a couple of UNLV freshmen sneak into this group, right? It's not going to be perfect. We want it to be as perfect as we can get it. But there's always going to be some difference between who the population is and the sample that's representing them. We want it to be a good quality and a good representative, but it's never going to be exactly right. So let's say we know that for our population of, we're just going to say CSN students, we'll change the example, of all CSN students, that they take a particular reading test, and we know, because everybody had to take it, that the average score was, say, 500 points. Well, if I just pull a sample out and give them the test, their average should be close to 500 points, but it won't be exactly right, because the sample will be off a little bit. It might be a little higher than 500, it might be a little lower than 500, but there's going to be some error. So sampling error is the term we use. This describes the natural difference that exists between the statistic value and the parameter value. We know they're going to be off a little bit. That score of 500, we know the parameter is supposed to be 500, but the statistic, maybe it'll be 480, maybe it'll be 505. It won't be exactly right. The more high quality the sample is, the less that difference should be. The worse quality the sample is, the bigger that difference will be. So if we've got a really lousy sample, let's say I just asked 3 people. That's it. Out of, 30,000 CSN students, I just asked 3. That person, and that person. And they said vanilla, vanilla, and strawberry. Well, I'm probably having quite a bit of sampling error. There's no way I've represented the entire population well. So the data I'm going to get, the statistic I'm going to end up with, is going to be more error prone. It's going to have more sampling error in it. Okay, on to the next video.